dewatered sludge with 22 to 26% dry matter, generated from Bursa East and other Buski treatment plants, is hauled in by trucks. The trucks are weighed on scales, and sludge is dumped into a 4-chamber underground bunker with a total capacity of 3,000 cubic meters. Progressive cavity pumps located below the bunkers convey the sludge to the above-ground intermediate silos. The sludge is pumped from the underground bunkers to 2 above-ground silos, each with a capacity of 118 cubic meters. The progressive cavity pumps installed below these silos convey the sludge to the 2 parallel fluidized bed incineration systems. The odorous air collected from the bunkers and silos is sent to a biofilter for odor removal. Air from the fluidizing air blower is heated up to 588 degrees Celsius by a preheat heat exchanger and primary heat exchanger, utilizing heat from the flue gas. The hot air is sent to the incinerator for combustion and fluidizing the sand bed. The sludge, with a 3,600 kilocalories per kilogram heat value, mixes with this hot fluidized sand bed and combustion air and is burned completely in 5 seconds at 868 degrees Celsius and is converted into inert ash and flue gas. Hot flue gases leaving the FBI first go through a primary heat exchanger. It heats the fluidizing air coming from the air blowers up to 588 degrees Celsius. This heat recovery process minimizes or eliminates the use of any supplemental fuel in the incinerator. After passing through the primary heat exchanger, the flue gas temperature is reduced to 658 degrees Celsius. The heat of the flue gas is then utilized by a water tube waste heat boiler to produce superheated steam at 41 bar and 450 degrees Celsius. The 2 boilers combined generate 12 tons of steam per hour. The combined steam from the waste heat boilers is sent to a 9-stage steam turbine, generating 2,500 kilowatt-hours of electricity. Flue gas containing dust and particulates from the waste heat boiler goes through a series of multi-cyclones for particulate reduction. Each unit consists of 81 mini-cyclones and uses centrifugal force, which is created by the spiral gas flow, and collects particulates larger than 4 microns, thus resulting in a 75 to 85% particulate removal. The removal of hazardous materials present in the flue gas, such as mercury, dioxins and furans, is achieved by the injection of active carbon after the multi-cyclones. In addition to active carbon, lime is also injected to remove acidic compounds, such as SO2. After this reactor, the flue gas enters a jet pulse baghouse filter. Each baghouse consists of 3 chambers, with 352 filter cartridges. While 2 chambers operate, one is offline, being cleaned by airjet. The cleaning is automatically controlled and initiated when differential pressure measurement across the filter is high. The particulate residues collected by the multi-cyclones and the jet pulse filters are stored in separate silos to be hauled away for disposal. This system comprises of 3 separate heat exchangers. This equipment enables the preheating of the fluidizing air and raises the stack gas temperature to a minimum of 140 degrees Celsius for plume control. Although the required emission limits are specified to be achieved after the bag filter, a packed bed scrubber is installed as the last stage of emission control for polishing. The ultimate removal of the particulates and SO2 removal by caustic scrubbing are achieved at this stage. For NOx control, a urea dosing system is installed at the top of the furnace to be used if necessary. The induced draft ID fan pulls the flue gas from the primary heat exchanger and is sent to a common 40-meter high steel stack between the 2 incineration lines. The emission values of the stack gas are monitored by a state-of-the-art continuous emission monitoring system.